feel free to write everything down here. What's all this nonsense here, right? Angle of elevation should have gone angle of depression, right? One of them should have been a D. Height, doing some conversions, supplementary angle. So these are like keywords that this AC covers. So Amrinder takes his boat out for a spin. He's heading towards a cliff. Probably important to realize, right? You're heading towards a structure that goes up. He notices that Dwayne the Rock Johnson is standing at the top of the cliff. Amrinder stops and estimates that the angle of elevation to the top of the cliff is 50 degrees. That's important. Amrinder continues to travel another 200 yards, travels another towards the cliff. So he's getting closer towards that building structure. You have it to take a better look. Stops and estimates that the angle of elevation is now 60 degrees. Sketch this diagram, label it as much as possible, show your work. Okay, so here we go. Is it a bit blurry? No, we're good. So I'm going to use a ruler, probably better. So I'm imagining this is the ocean floor. No, not the ocean floor, the surface of the ocean, which in our case is going to be nice and flat, right? Even though it isn't. And then the cliff is going to go, we're assuming is vertically. We couldn't, right? Unless the question tells you otherwise. But we know that we have Amrinder, right? So this is Dwayne the Rock, right? Up there. This, at the very beginning, this would be Amrinder's first location, right? So Amrinder's looking up and estimates that the line of sight and its angle of elevation, so it has to be from the ground up. We know that that's 50 degrees. Okay, that angle of elevation. Let me zoom into the picture for now so you can have a better look at it. It's better, right? There. And then so we move it. He moves 200 yards in, so somewhere in here. It's not drawn to scale, but this is Amrinder's second position. Okay? So then looks up again, and it makes sense that the angle of elevation is 60 now, because it's measured right from the ground, from the horizontal up. So we get there, 60. We can insert the 200 yards in here. So from end to end, from first location to second location. And is there anything else we're missing? We're assuming this is a 90. Unless we're told otherwise, we're assuming the cliff is going straight up. Okay? Label it as much as possible. So for me, this would be a 2 marker. If you got all the pieces in that I just showed you. Sometimes I ask you to fill it in with as much, even adding angles that are not immediately visible, but you can add. So for example, I will do that using a red pen here. Supplementary angles here. So I know that this is 120. Right? This is 120 here because they add up to 180. If this is 50 and that's 120, that's 170 already. So this sliver up here is 10. Right? This is sum of triangle. This is supplementary angles. So I'm stating the property. You don't have to do that. I'm fine just leaving it like that. I think we've got enough going on here. Okay. For now. Okay. Calculate the direct distance between Amrinder's second stop to the rock. Right. So this is the second stop. It wants this. The direct distance is this. This could be the horizontal distance. This would be the height. Right? So we will call this, I don't know what you want to call it, X. Right, this side right here. And let's start solving. What law are we going to use? Sine law. That's right. I'm just going to say this one right here is across that right there. We've got a pair. Okay, so we can answer B using sine of 10 degrees over 200 yards. And then we're going to go sine of, you got to be careful here, you're going to use sine of 50 because that angle is across the side you're interested in. So I would say if you didn't pick 50, you have to take off one mark there. So this would be x. Okay? And then x would be cross multiply and divide. So 200 times sine of 50. And I do this on purpose. I want the 200 in front of sine so that there are no issues whatsoever. So when you multiply that and divide, I get 882.29 yards. It's within reason, because if across from 10 you've got 200, across from 50 you would expect a longer side for sure. So I would say if you missed an angle, or if you're pairing up the wrong sides, that's for sure a -1. And then I have to see, how did you go from there? Was everything else consistent, right? So this answers B, so we can circle that. And then for C, what's the height of the cliff? I will use, for height, I will use side x, and I'll multiply it by sine of 60. Like that. Because I have that slant, which is 882.29. I just multiply that by sine of 60, and I get 764. I don't really care how you got it. Actually, I don't care how you got either one of them, as long as you show me the work. You're good to go. Any questions about this? Remember, recall, height is slant, okay, times sine of angle. Right? This angle is between slant and base. Okay, that's important. Oops, you cannot see it. There. That's just fun stuff. I know. So that's one of these scenarios. I'm going to the next question here, because two ships leave the same port. Boat A travels at 20 miles per hour. Boat B travels at 25 miles per hour. Okay. After 3 hours, they're 110 miles apart. Calculate the angle formed between their paths. Provide a sketch as well. Okay, so you're thinking, right? This is the port, and you've got two boats leaving. We don't know in which direction. We don't. But we're just going to assume boat A goes here, and then boat B goes somewhere over here. Okay. We know that after 3 hours, they're 110 miles apart like that. So now we need to figure out this and this. To figure out A, we just go 20 miles per hour times 3 hours. Okay, so that's 60 miles that boat A will have traveled. In which direction, we don't know. This one, boat B, is 25 miles per hour times 3 hours, and that's 75 miles. So I would give you, if you sketch something like this and you have those parts and the conversions there, I'd give you 2 marks for that because of the conversion piece. So that's how you got 75. This is how you got the 60. And so now, what does it ask for? Calculate the angle formed between their paths. It's asking for this angle right there. So what's this? Sine, side, side, side. Yeah, cosine law. That's right. So we're solving for that angle. So you got to use this formula. Cosine of P. Remember, you want the side across the angle you're interested in to be back here. And make sure you square it. And then you take the other two sides, square and add. Okay. And then it's 2 times 60 times 75. So this 110, whatever this side is, does not show up anywhere else, only back here. We figure out what the top is. If you enter that, you get negative 2875. Don't let the negative throw you off. It's okay. We know that it's an obtuse angle. If it's a negative, it's obtuse. If it's positive, it will be an acute angle. If it's 0, it's going to be exactly 90, by the way. If it's ever 0, if you get a 0 at the top, don't panic. You're just getting a 90. Inverse of 0 is 90 for cosine. So we go cosine P. I'll do one more time. I'll divide these. I get negative 0.319 and something. And here's the critical step. Right? If you're trying to find an angle, you got to take the inverse of both sides. Don't square root. Square root has nothing, right? There's nothing squared here on the left-hand side. So don't square root. That's not the right step here. And so this is 108.63 degrees. I'll change the total on this one because it's, I would say, if you set it up and you get the negative, like this part right here, I give you a mark, and then another mark for this. So we've got 2, 3, 4. Okay, so you just get kind of cross this out and just put a 4 underneath like this. So that would take us to 3 and 2, it's 5, and 1 is 6, and 4 is 10. So this page is worth 10 marks. We're good? Still with me? I know, my voice. If I told you this already, if you have a hard time falling asleep, just turn on one of my videos at night and you'll be like gone, right? Right. The U.S. military has air balloons flying over the international waters to monitor the ocean for potential threats. On a particular day, while flying 9,000 feet above water, that is height or altitude, right? The balloon spots an unidentified ship marked U at an angle of depression of 65 degrees, and a cruise ship called C at an angle of depression of 45. Assume that the balloon is between the two vessels that have been spotted. That is a very important detail. Because if it didn't tell you that, we would have various situations here and it would make it very messy. Okay. Create a diagram for the scenario. So here we go. So the balloon is somewhere up here and we call it, I didn't call it anything. Oh yeah, we're just going to call it B. Guess what? That's what we're going to call it. And spots a U, right? Unidentified ship at 65 degrees. So I'm just going to make it be to my left because that really doesn't matter. But I'm going to have a horizontal looking at either side. You have to have a horizontal there up in the sky. So it's 65 degrees to that unidentified ship. So 65, I actually am going to start doing the arrowheads, right? That's 65 degrees right there. And then the cruise ship is at a 45. So I'm going to make it slightly smaller. Therefore, it's a bit of a longer side. So that's C. This is 45. Right? And so we're assuming Right? This is the surface of the ocean, right? That it's horizontal there at the same height this way. So there you go. We still need to put the 9,000 in there. And in this case, it would be right here. This is 9,000 feet. This is going to bring me to a point as I was marking your ACs, some assumptions you guys were making. 2 marks for this. So if you have this, right, if it's like this, except for obviously you could have the 65 on one side, 45 on the other. I don't care about that. You get 2 marks. Has to have all these components there. You can have different letters. I'm okay with that as long as you identify what's what. Calculate the distance between the vessels spotted by the balloon. So we want distance UC. And this distance UC, right? That's what we want. So how are we going to do that? Well, I'm here to tell you if you have a height, you've got to work with the right triangles. Okay, I'm going to say something here. I hope you remember. Some of you were splitting this. So on the AC, this was 15. I gave you this, and so you were like, oh, 7.5, 7.5. You can't do that unless you've got an isosceles triangle. But look at this. This is 45, right? We know that 45 is going to come in here. 65 is going to come in there. It's not isosceles, right? So you can't assume they're the same. To be honest, I would just not assume that they're the same. Only in the very rare circumstance where it's an isosceles triangle. Okay, so should I make a note here? I think I'll do that in our notes maybe later on. So here we go. I'm going to approach it X and Y. I'm going to do one at a time. I'm going to bring some red ink into here. This is 65, alternate interior. This is 45. And so you got to be careful, okay? Listen carefully here. Is it possible to get this entire angle up here? The answer is yes. Is it helpful? I don't know, because you need to kind of pair something up with the 9,000, right? Which is, if you use 9,045, then hey, you're now bound to this right triangle here. If you're pairing 65 with the 9,000, guess what? You're now bound to that right triangle. Some of you are going small triangle, large triangle, like you were skipping triangles. You can't do that. You kind of have to decide which triangle am I bound to, okay? So here's my strategy. I'm going to do this one. Sine of 65 over 9,000. And I need to figure out x here. So how am I going to achieve that? I'm going to figure out this little sliver here. And 5 gets me to 70. So another 20 gets me to 90. So this is 25 here. Just this part right here. So I have to use sine of 25, because I'm bound to the right triangle here, over x. Don't erase if you did it. It is possible to do this differently. It is. But maybe not right off the bat. I would say not right off the bat. Once you solve more, you can do it differently. Okay, here we go. X is equal to, right, 9,000 times sine of 25 over sine of 65. Make sure you show me that intermediate step, right? That work piece there. I get 41.96. Is it 77? 77. And we have feet. Can't read my own writing. It's pretty sad. There we go. Question. Mr. Dirksen, should I have done 4 decimals here? Because I'm not quite done. I would argue yes. I would argue yes. But right now we're just gonna leave that. Next, I need to find y. Okay, so I'm gonna go sine of what? Sine of 45 over 9,000. And now I'm going to use y, I'm going to find y, but y, watch this, is bound to this right triangle, so you need to figure out that angle up there, which is what, 45, correct? 45, 45, that's 90, and we do have a 90 here as well, right? Either side of the height, we have a 90. So what do you think is going to, what do you think is going to happen? If sine of 45 is 9,000, what do you think this side is going to be? It's going to be 9,000 as well, right? Because it's just, if this is 45 and this 45, you better have 9,000 on both. But if you didn't notice that, guess what? You'll still get the same answer. But look at this. Sine of 45 divided by sine of 45, that kind of cancels out. So y is just 9,000 feet. So that's just an added, it happens. It does happen from time to time. So UC is 4196.77 plus 9,000. Why do I put a dollar sign? 13,196.77 feet. And I'm going to break this down into marks for you to figure out what you should be getting. I would say if you have this correctly set up to solve for x, right, you get a mark. And then if you do the work, you get another mark. So if your setup is not good, but your work is consistent, you get 1 out of 2 on this one. Same here. 1 for setup, 1 for correct answer and consistent work. Then I give you another mark for actually adding the two, the x and the y together. So that would bring this out of 5. And so here we're going to make a change on B here. We're going to cross off the 4 and just make that a 5, like so. And then I snuck in the, what's the distance in kilometers? I don't know. It should have been okay to do. Okay. So C, I'm going to go 13,196.77 feet times, what did I use? I used 1 mile, has 5,280 feet. Cancel, cancel. And then I went with 1 kilometer, or sorry, 1 mile has 1.6093 kilometers. That's pretty tight there, but you get it. The miles cancel out, so you're just left with kilometers there. So you go this times 1 times that equals, hit enter, then you divide this by 5,280 times 1, which is just 5,280. You got to make sure you put this in brackets if it's not times 1, because you're going to be in trouble. So that is the equivalent of 4.02 kilometers. You get a mark for that. And of course, if you got a different answer for the distance in feet, you would get full marks here if you still show me the work that you put in. Like basically, if you do the steps here, you still get the mark. Okay, regardless of what you got for B. And then a blast from the past. Let's see. The interior angle of a regular polygon measures 171. How many sides does it have? I'm going to go like this. Remember, the interior and the exterior angles always add up to 180. So to get the exterior angle, all I have to go is 180 minus 171. So the exterior angle is 9 degrees. So exterior angle is also 360 divided by number of sides. So I put the 9 in here, put a 1 underneath it, you cross multiply and divide, you get 360 times 1 divided by 9, n is equal to 40 sides. Don't like that one? But wait, there's more. Okay. The interior angle is n minus 2 times 180 over n. Okay, so you plug in 171 here, and then you have n minus 2. I'll distribute that right away. I'll distribute this, right? So it's 180n minus 360. It's good review. Over n. At this point, you can multiply both sides by n. Cancel out the n's here. So you end up with 171n is equal to 180n minus 360. You subtract 180n from both sides. You end up with negative 360. And here you end up with negative 9n. And you'll see that you get the same answer, right? Because you divide both sides by negative 9. N is equal to 40 sides, regardless. So I'll give you 2 marks if you get this final answer and you show me work for it. So this back page is 5 and 2 is 7 and 1 is 8 and 2 is 10. So the back side is now worth 10 as well, and the front is worth 10. So it makes the total out of a whopping 20 after all. Okay, so make sure your name and last name is on there.